We're going to be looking at absolute value expressions and equations. When we think of absolute value, you want to think of distance from 0 on the number line. So 5 is 5 units away from 0 on the number line. So the absolute value of 5 is 5. Now when we think about negative 5, absolute value of negative 5 is also 5. It's 5 units away from 0 on the number line. And we think of distance as always being positive. Now in number 3 we're evaluating the expression. So we're told that x is negative 4 and that y is 9. So replace x with negative 4 and replace y with 9. Now notice the minus was already in the expression. Absolute value is a grouping symbol. So just like parentheses, we do what's inside of it first. So inside of the absolute value we have multiplication and addition. We're going to multiply first. So 2 times negative 4 gives us negative 8. Now negative 8 plus 5 gives us negative 3. Now we still haven't taken the absolute value, we just did all the stuff inside of it. Now to take the absolute value negative 3, negative 3 is 3 units away from 0 on the number line. So absolute value of negative 3 is positive 3. Now we have 3 minus 9. 3 minus 9 gives us negative 6. So we evaluated that expression. We found the value of that expression. We got negative 6. So even though absolute value makes it positive, if there's things outside of it in the expression, then it can be negative. So the whole expression ended up being negative. Alright, if you're watching this via video, I want you to pause it and then work out these 3 problems and then press play again. Alright, so you're finding the absolute value of negative 7. That's 7 units away from 0 on the number line. So the absolute value of negative 7 is positive 7. Absolute value 27. 27 is 27 units away from 0 on a number line. So you get 27. And then for number 6, substitute in place of x, put 2. And in place of y, put 6. Do what's inside of the absolute value. We have 2 minus 7, that gives us a negative 5. Absolute value of negative 5 is positive 5. And now 5 plus 6 gives us 11. So the value of the whole expression is 11. Here we have an equation. We're trying to find or solve the equation that has the absolute value of x equal to 3. So think about what numbers you can take the absolute value of and get 3. If it helps you, you can look at a number line and go 3 units away from 0 on either side. If you go to the right 3, you're at 3. If you go to the left 3, you're at negative 3. So the absolute value of x equal to 3, x could be equal to 3, or x could be equal to negative 3. Now you can check it by substituting those values in and seeing if you get the same number on each side when you simplify. So if we substitute the 3 in, absolute value of 3 equal to 3. Absolute value is 3 3 equals 3, that checks, that works. If we check the other solution, absolute value of negative 3. Absolute value of negative 3 is also 3. It's also 3 units away from 0 on the number line. So we have 2 solutions. Now when we think about number 8, what numbers are negative 9 units away from 0 on the number line? Well, we don't think about distance in terms of negative numbers. Now you might say, well, maybe it's 9. So if you think about checking absolute value of 9 equal to negative 9, absolute value of 9 is 9. 9 equal to negative 9 is false. It does not work. So 9 cannot be a solution to this. You might think that negative 9 is possibly a solution. So the absolute value of negative 9, check that. Absolute value of negative 9 is also 9. 9 equals negative 9, that's false. That is not true. So if you have the absolute value by itself, so nothing else on that side of the equation, equal to a negative number, then it's just going to be no solution. There is no number that we can take the absolute value of and get a negative number. Now this is again different than when we saw expressions, where we saw that an expression that happened to have an absolute value, but then by the time we evaluated everything we got a negative. So you can't take the absolute value of something and get a negative number. Here we have the absolute value by itself equal to 5. So that stuff inside of the absolute value, the 2x minus 3, that stuff could equal 5, or that stuff could equal negative 5. And so we'll have two different equations that we need to solve. Once you got rid of the absolute value, now you have just a two-step equation on this one. To get rid of minus 3, add 3. So we have 2x equal to 8. To get rid of multiplying by 2, divide by 2. And so we have x equal to 4. To get rid of minus 3, add 3. So you have 2x equal to negative 2. Get rid of multiplying by 2, divide by 2. And so x equals negative 1. So we have two solutions, 4 or negative 1. You can check it by plugging them back in, and evaluate it on the left side, making sure it comes out to be 5. But both of those will work. On number 10, we have the absolute value by itself equal to a negative. Now think about this. There's no number that or expression that we can take the absolute value of and get a negative. So the absolute value of x plus 1 equal to negative 4, since the absolute value is by itself equal to a negative number, it's going to be no solution. There's no number that we can take the absolute value of and get negative 4. Alright, pause the video and try these three problems. Alright, number 11, you have the absolute value by itself equal to a negative. There's no number that we can take the absolute value of and get negative 10. So number 11 is no solution. Number 12, we have the absolute value of x equal to 25. So that means x could equal, if we think about going 25 units away from 0 on the number line, if we go to the right, we're at 25. If we go to the left, we're at negative 25. Each of those numbers we can take the absolute value of and get a negative. And then 13, we've got the absolute value of x plus 7 equal to 3. Absolute value by itself equal to a positive number. So we can write two equations. That stuff inside of the absolute value could equal 3, or it could equal negative 3. So we have two equations to solve. To get rid of plus 7, subtract 7, and we get negative 4. To get rid of plus 7, we can subtract 7, and we get negative 10. So we have two solutions. X equals negative 4 or x equals negative 10. You can check both of those by substituting them back in.